Hello everyone, Jai Jagannath. This is one question of CSIR December 2025 and this is question of real analysis. So let's read the question first. Okay, what is given? Which of the following statement is necessarily true? Which of the following statements is necessarily true? इन स्टेटमेंट से, इन चारों स्टेटमेंट से कौन सा नेसेसरीली ट्रू है? Okay, let's read the first option. The set of all finite subsets of Z is uncountable. Here is what is asked. What is given? The set of all finite subsets of Z is uncountable. So you should know two things about the collection of subsets of a countable set. Okay, so I am writing here the collection of all finite subsets of a countable set is always countable. And second में क्या है? The collection of all infinite subsets of an countable set is always uncountable. The collection of all finite subsets of a countable set is always countable, and the collection of all infinite subsets of a countable set is always uncountable. So let's see the first option. In the first option, what is given? The set of all finite subsets of Z is uncountable. This is wrong. Why? The set of all finite subsets of Z is countable. Why? Because Z is here. Z is what? Z is countable. So the collection of all finite subsets of a countable set is always countable. So this is wrong statement. Then read the second statement. Next option. Let function from R to R be a continuous and one function if S subset of R is a countable infinite set. That means S is countable infinite subset of R. Okay, then Fs is a countable infinite set. So let write the question, write the option. What is? F is continuous and 1 Okay, as F is 1 from the definition of 1 function we know that for all R not equal to S, that means R and S belongs to which one? R and S belongs to the domain of F. Then in codomain what will happen? F R not equal to Fs. If R not equal to S, then F of R not equal to F of S. Okay, and then what is given? S is countably infinite set. S is countably infinite set. That implies S contains countably infinite distinct elements. That implies their images of the elements of S will be different. As F is 1 as F is 1 that means as all the elements are different in S, then their images will be different in the codomain. That is right. Then you can clearly say that F of S cardinality is greater than equal to S की cardinality. Can you say or can't you say? Because as we can see, what we can see, all the elements of S are different. As F is 1 दो डिफरेंट एलिमेंट्स की क्या इमेज एक नहीं हो सकती, नहीं होगी, दो एज वन वन, देन टू डिफरेंट एलिमेंट्स की इमेज एक तो हो ही नहीं सकती, तो दोनों की इमेज क्या आएगी, अलग अलग दो ही आएगी, तो ऑल द इमेजेस ऑफ एस विल बी डिफरेंट, दैट इम्प्लाइज एफ ऑफ एस ग्रेटर देन इक्वल टू एफ ऑफ एस की कार्डिनलिटी ग्रेटर देन इक्वल टू एस की कार्डिनलिटी in general by the definition of function we know what will happen, f of s की cardinality less than equal to s की cardinality. From equation I and second I, what you can conclude, from I and second I we can conclude that f of s की mod equal to x s की mod, that implies s की cardinality क्या है, countably infinite, that implies so f of s will be what, countably infinite. So here we proved these things. तो आंसर क्या होगा, बी तो करेक्ट है. ये एक पार्ट बी का क्वेश्चन है, क्या पार्ट बी का क्वेश्चन, मतलब सॉरी ये ऑप्शन बी में लिख लिया, ऑप्शन 2 करेक्ट है. ओके, ऑप्शन 2 करेक्ट है. मैं यहाँ ये पार्ट बी का क्वेश्चन है, क्या है, पार्ट बी का क्वेश्चन है. पार्ट बी में क्या होता है, एक ही आंसर करेक्ट होता है. तो हमने देख लिया कि 2 करेक्ट है, 2 करेक्ट है. if you are sure you have proved, then no need to go to third and fourth option, because in part B there is only one option is correct, so don't check third and fourth option, save the time and go to next question. But here I will read and show you these 2 options. Okay, but in exam what will you do, in exam just skip, इधर से ही रुक जाओ और मत थर्ड 4 ऑप्शन मत देखना, टाइम वेस्ट हो जाएगा. हमको एग्ज़ाम में टाइम वेस्ट नहीं करना है, हमको टाइम क्या करना है, सेव करना है, ताकि हम थोड़ा ज़्यादा क्वेश्चन कर सकते हैं. ओके, तो यहाँ पर ही रुक जाना. तो लेट्स सी इन थर्ड क्वेश्चन, फंक्शन फ्रॉम आर टू आर बी ए कंटिन्यूस फंक्शन, देन देयर एग्जिस्ट एन अनकाउंटेबल सबसेट टी सबसेट ऑफ आर सच दैट एफ ऑफ टी सबसेट ऑफ आर इज ए अनकाउंटेबल सेट. क्या बोल रहा है, फंक्शन फ्रॉम आर टू आर बी ए कंटिन्यूस फंक्शन, here is given that f is a continuous function. It's okay. Then what is saying, then there exists an uncountable subset, t is a uncountable subset, is subset of r such that f of t subset r is uncountable. What he actually saying, he is actually saying that f function from r to r is continuous and t subset of r is uncountable, then f of t also will be uncountable for some t, because what is given in that question, in that option that is given, there exists an uncountable set. Okay, she is not telling that for all the uncountable subsets, she is telling there exists, and there exists is this option is telling that there must exist one. There can be more than one, but there exists one uncountable subset such that f of t subset equal to r is also uncountable. So I have an example for this question. This is true or false, ये हमको देखना है. ओके, if I will take function from r to r such that f of x equal to 2, then if let t be an uncountable set, then f of t will be what? F of t will be only 2 content, which is singleton set. So here, can you find at least one T, one subset of R which is uncountable, but and their function after then f of t will be uncountable? No, here you can't find such T, so this is not correct for all f. So that option will be what? False, wrong. Then how do we happen? This will be wrong statement, wrong option. Okay, did you get that? Or if you didn't get that, then just ask me in the comment section. Okay, I will help you. So let's see the last option. Function from R to R be a continuous function if R subset of image of f is a countable set, then f inverse R is countable. Here R is real number, but here R is not real number, it is a subset, it is a subset of image of f. Okay, let's see what happens. Here what is given? F from R to R, real number to real number. What is it? Is continuous. And here from image of R, here is a subset of R. Okay, R is subset of image of f, and what is given? R is countable set. Okay, here is to show. Here is what is to show. In that question, what is given? That question is given that you have to show that you have to check that f inverse R is countable. R can be any subset of image of f which is countable. R must be countable, but R, then if R is countable, then f inverse R is countable. She is saying. So we have to prove this is true or false. Okay, so let's see what will happen. Let's take function. Let's take example. I am giving an example. Let's take a function from R to R, such that same function given in the last of question option. Okay, f of x equal to 2. Then can we take R as 2? Because this is countable set, then here R is what given is countable set and subset of image of f, then this is f of R is a countable set and also a subset of image of f. Then if we'll find f inverse 2, then what will happen? It will be whole R. Okay, because it is constant function, then its inverse will be whole R, which is what? Uncountable. Okay, uncountable, it is not countable. So what? This one is false. So what happened? So this one is what? False. So in this question, which option is true? Is the second option. Okay, if this question helped you, then do like and share, and please comment and do subscribe my channel. Thank you. Jai Jagannath.